Crazy. Okay. Never mind. So this is the contest detail. This is the contest which we are going through, right? So there were some problems, and let's see. So which problem you had issues with? Prime checker, right?
Prime checker, yeah,
And
prime checker, and sum of odd elements, I think.
this one, I think this one is easy problem, but we don't have the language to select.
Oh yeah, yeah. This
Yeah.
thing we
So
didn't do.
yeah, we don't have language to select here. So well, and any other interface maybe?
Yeah, I think interface and prime checker is which I failed. There was
Okay.
one with the logic which was very complicated. I
Okay.
think it was which one it was. I don't know. Let me check.
Okay.
Yeah,
So
here I got.
this one,
I got it. Um,
you just
prime
need
checker.
to prime checker only.
Yeah, and the other one I don't remember it. I got my
Divisor
first.
sim,
It was inheritance.
inheritance. Okay.
Yeah.
Um, inheritance two. I think this one you solved already.
No, no, sir. Loops. Sum
Loops.
of odd
Okay.
elements and loops.
Hmm.
Yeah. Sum
Okay.
of odd elements, loops, and prime checker.
Okay.
These
Let's
three.
go with loops first. Okay.
Okay.
Select Java 8. So we use the integer a, b, and n to create the following series. So we have this series, and we have input format, and I think input is already given. So we just need to write the logic only. So we have input. So we have two lines. First one is q. Second one is a comma b, and then wait, what is this? Okay, first one is a b a plus 2b a b n. First one is a b and then n. So we have number of test cases here. So we have two test cases, first one, second one, something like that. And the first is a, so this is a, this is b, and this is n. And a and b will always be greater than equals to 0 or less than equals to 50. N should always be less than 15 or greater than 15. Sorry, greater than 1. Okay. Now, where is n? So n is the power of 2. Okay. Okay. Makes sense. Alright, so we just need to print the value after the computation, 2, 6, 14. Hmm. Just write a for loop which starts from 0, and it should start from 0. Let me check. So we have a, b, n minus 1. So in the first loop, we'll be having, okay, what is the n? Okay, we will be going till n. Yeah, n minus 1 perhaps. So n I plus plus. Okay, so in this case, we'll be printing out something. So we'll say the system dot out dot println. Not print, and just print, and we will print the value. Okay, so first is a. So a starts from, let me check. A should be 0. We'll just print a plus math dot pow 2
because
comma
the power.
sorry.
Okay, okay. 2 power
Yeah,
I, okay, because I is n.
yeah,
Okay.
correct, correct. So I think we need to print this, and yeah, I think that's it.
Sir, in the string args should be
Sorry.
in the public static void main
Yeah,
string args, not argh, because they I think purposely put
it
this
doesn't
over there.
matter because this is just a name. You can give it Zishan as well, and it will work fine. Okay.
Oh, okay, okay,
Yeah, so it's just a name. Don't worry about that.
okay.
So I think it should be fine. Let me check. Yeah, should be fine, I guess. Let's run the code and see. It says we cannot find the. Oh, okay, okay. So it's a local variable. Okay, never mind. So what we can do is we can create that loop here and should be fine now. Let's run the code again. So it says I is already defined. Okay, so we need to give it some other name. Let's say J again, J again, and here as well, J. Let's run it. So we have output in decimal, but we want an okay. Now the problem is math.pow will return a double value. So we need to explicitly tell this that we want integer only. So it should be fine, but I think we are still getting some errors. So I think it's some logical error. Yeah, I think. So our output is 2, 4, 8, 16. So are we doing something wrong? Let me check. Okay. So in the first iteration, we want to add this, but in okay, understood. So in our first iteration, we want this. In the second one, we want to go from 0 to 1. So we'll be adding the previous values every time. Okay.
Okay.
Hmm. But we don't want to use another for loop for that, so we can pre-compute it. So we are actually pre-computing it. So let's say the pre-computed value. mm, Oh my God, is a plus int math dot pow 2 comma j comma sorry b. So this is our pre-computation value, and or you can say this is our sum. Okay, so sum plus um just a sec. Sum should be 0. So sum is equals to sum plus this value, and then we will print that value here. We'll print the sum, and I think it should be fine now.
Sir,
So
one confusion.
yeah, what happened?
Inside the for loop, there is another for loop.
Yeah, I know. That's
Oh, okay,
called
okay. It
nested.
works like that.
Yeah, it works. So I think you are not aware of this. but this is called nested loops. So suppose if you
Oh,
are iterating over a matrix or something, so we create one loop, and inside that we create another loop.
okay.
So it says it's not passed again. I think something is wrong with the output. Let me check. Phew. Okay. In the first iteration, okay. I guess I have to create this variable here. Should be fine now. So sum is equals to sum plus a plus. Okay, let me run it again.
Hmm.
Still, I think our output is matching for the first case. For the first
Oh,
case, it is matching, right? But for the
yeah.
second one, it's not. Should not happen. What is the issue? Let me check here. So in the first case, it is matching. No, here it's not matching. Something is wrong. A plus 2 raised to the power 0 into B. A plus, okay. A plus this. Then we are saying A plus. Let me check. A plus this. And in the second iteration, it is adding A again. Hmm. I think what we are doing wrong is adding that A. So if we say that if sum is equals to A,
Yeah.
so now we um yeah, should be fine. Okay, so all the test cases are passing. So this is the solution, and it is a little difficult for you, I know. But let's understand the solution, how we got the solution. Okay.
Okay.
So man, now what we are doing in this case. So we want to print something like this. Just let me go through the problem again. So in the first iteration, so we will have total of n minus 1 operation. You see here, n minus 1.
Yeah.
So we have total 0, 1, 2, 3, 4, dot, 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 till n minus 1. So we have these many operations to execute. Okay, all right, no issues. So we know that we need to iterate this much times from let me from 0 to n minus 1. We need to iterate, right? So we need to iterate at least 0 to n minus 1 times. So that's why we are creating a for loop for j is equals to 0 to j minus 1, n minus 1, okay, j plus plus, right?
So that
Yeah,
is n. I mean I. Sorry, I. Or
yeah,
not
no
I.
worries, no worries. It's just a variable.
Okay, like I'm referring to the code. That's why, sir. Which you wrote.
Even in the code I wrote, I think j only.
J. Okay, it's in the solution, I think.
Where it is.
You
Uh,
copied? Did you copy it?
no,
The code?
no worries. I can still.
I was writing it.
No worries. I can again write it. You know. So you know.
See, in that
Uh,
up thing where there was a solution problem and all that.
your voice is breaking.
And
Okay, no worries, no worries. I'll just go through it again and explain line by line. Okay. So
that row where
in
it
this
was
case,
written,
you are seeing right. So this is a scanner, and this is taking input
I'm
for
saying
T, right?
in the row where it was written
Your
problem,
voice is
solution.
breaking. Can you hear me?
Okay, sir.
Can you hear me?
Uh-huh.
Can you hear me? Can you reply?
Yeah, sir, the network is really bad.
Okay, okay. So let me go through the question again. I'll write the code again. Don't worry about it. So in the question, we have two test cases, right? So we are taking input for test cases. So T is the number of test cases. Here we are taking the input for test cases, and then we are iterating over that much time. So we are iterating over the number of test cases. Okay.
Mhm.
Yeah. So after that, after iterating, what we need to do, we took the input for A, B, and N, and after that we will be doing the operations, right? So just a second. So this one. So we are taking input for A, B, and N, and after taking input, we are saying that sum should, or we are just creating another loop, nested loop. This one is a nested loop. We are saying int j is equals to 0, and we are saying j should be less than n minus 1 equals to. Then what we are saying, now you see that in the first iteration we want this value, right? So in the first
Yeah.
iteration we want the sum. So let's say we are printing sum, okay? We are just printing the sum. Yes. Let's say we are just printing the sum, okay? And this is the value for a sum. Now we just want to calculate that sum, okay? So we are
Okay.
saying sum in first case, in first case, sum should be equals to a plus um math dot pow 2 comma I, right, into b. So in the first iteration we want this, okay?
Mm-hmm.
You see this, right? Now,
Yeah.
but what should be the case of second iteration? In the second iteration, we want, let's say this is sum 1, right? Let's say this is sum 2. In second iteration, we want the A, and we want math dot pow 2 comma, let's say the first one is this, okay? Never mind. In the second case, we want 0 into B. I'm sorry, there's a lot of background noise. Can you turn off your mic?
Yeah, there's a bus passing. Okay.
So you see, this is your sum 1, and sum 1 is A plus math dot pow 2 comma 0 into B. Now what is sum 2? Sum 2 is A plus math dot pow 2 into 0 into B plus math dot pow 2 comma 1 into B. Okay. Now you just need to understand, we want to create something which is general. Okay. We want to create a formula which is general. So if we say what is the difference between this and this? So the difference is this, right? Okay. So, and let's say we have a third value as well. So we have a third value. Let's say sum 3. It should be again math dot, like it should be this plus maths dot pow 2 comma um 2, right? For the third case, we want the formula to be something like this. So you know what we are adding continuously. So we are adding something like this, right? So we are adding the this value, okay? But what is a common value? You know, so the common value for someone is a. This is the common one. Like this should be the starting point, right? And after this, we can add this value, and after that, we can add this value into it, and add this value into it, right? So the
Yeah.
entrance point for the someone is sum 0 is a, right? We have a, then we add this to a, okay? Now,
Mm-hmm.
can we say that this is your someone, right?
Yeah.
Can you say that this is your sum 2?
Yeah.
Now we are almost close, but we want our logic to be better since we are doing everything general. So we'll say that let's say we only have one variable, and that is int sum is equals to a, right?
Mm-hmm.
Okay, so we have this, so we can remove this. And can we say that let's say this is also sum, and can we say that is this sum? Can I say that a is equals to sum, right?
Yeah.
So can I say this is also sum, right?
Yeah. Yeah.
And this someone is now sum, so can I say this is also sum?
Yes.
And let's write this, and this sum 2 is your sum, right? Can I say this is also sum and this is also
Some.
sum? Now can
Yes.
I remove this? Because the only thing which we are changing, right, is the 0,
The
1
power.
and 2, right? Can I say that this 0 should be j because j is 0?
Yes.
And in the first, like this is your first iteration. When this loop goes again, so this j will be equals to 1, right? So this is
Yeah.
also 1 in the second iteration.
Yeah.
So this is
Yes.
also j, right? So
Yeah.
we don't have to write this we are doing. I don't know why we are doing this. We are So it's
Example, I think.
unnecessary, right? This is unnecessary. So the only thing which we require is just this. If we create some initially, then we can just have this formula and we get it. So this is it. Now just print the formatting things. And this is it. I hope now you understood what is the concept behind it.
Yes, sir.
Now if you run it again, okay, what is the issue? Possible. Okay, so we need to make it integer.
Yeah, integer.
Everything will be good now. So that's it. All
Sir,
right.
there is two system out printing. The first one is for the
Yeah.
for the what I didn't understand.
Yeah. So the first one, you see the difference is in this print we don't have ln, right? And in
Okay.
the second system out we have ln, right?
Okay.
So if we don't have ln, we will print everything line by line. Sorry, not line by line, in a single line. We will print
Okay.
everything in a single line, space separated, okay? Because we added space here in the end, right? So everything will be space separated, you know.
Yeah.
And once we add the line, you see, so our when our first loop is done, we know that our first case is done. So our first test case is done here. Then we want to change the line, right? So this is our first test case. It is done here. Then we want to change the line for the second test case. Okay. Then we are taking the input for the second test case a, b, n, and then we are doing everything similar. Okay.
Okay.
That's how this works. If you're still confused, you can ask me, like, what is the exact point where you are confused. I'll just share you
No,
the.
no. Okay.
So, hope you're good.
Yeah, sir.
Okay. Mm, you can go through this code and let me know if you have any issues.
Yes, sir. I'm going through it. Sir, so the first system out print, it will print the things inside the for loop, right?
Mm, it will print inside for loop. Yes, correct.
And the second one, what will it print?
Sorry. What?
The second system out print ln.
This will just print the line. So it will go to the next line. So after
Okay,
10, it will go to the next line. That's it. So we are just using it for the new line.
okay, sir.
Yeah. Yeah.
Yes, sir. I even wrote it.
Can we go to the next question? The prime
Yes, sir.
checker.
You can. Yes, sir.
Okay. Uh, Prime checker. Okay. You're given a class solution and its main method in the editor. Your task is to create a class prime. The class prime should wait what? Should contain a single method check prime. So our task is to create a class prime. Let me check. Okay, we create a class prime and should contain a single method check prime. Okay, check prime. It's what? So it could be boolean, right? So we'll be having some values as well. Okay. Now what is the issue? The lock code in the editor will call the check prime method. Where is the lock code? I don't see it. Okay, never mind. Um, you should write the check prime method in such a way that the code prints only the prime numbers. Okay. Please read the code given in the editor carefully. Okay, let's go through this input. So we have a sample input. So there are only 5 lines of input, each containing one integer.
The sir, the second line doesn't print anything.
Yeah, sorry. I can't hear you. Your voice is breaking.
The lock
Your voice is
code
breaking. Can you write?
the code which they Yes, sir. I can hear you, sir. My phone. Yeah, I can hear you now, sir.
Okay. So, what was your question?
That time you're reading the question in the question when they said they've provided a lock code. Isn't the lock code which things they provided?
I don't see where it is, but it should be something which is checking in background, for the
Okay.
test cases, right? So never mind. I'll just focus on the input and output, and we'll just we'll try to code. Yeah. So we have 5 lines of input, so each containing one integer. So let's say we have what? We have 5 input, and there will be only 4 lines of output. Each line contains only prime numbers depending upon the parameters passed to check prime. In case there is no prime number, then a blank line should be printed. Okay. So I don't understand the what is the input and what is the output. So I know 2 is a prime number, right?
2, 1, 3, 4,
Should
5.
be. What are prime numbers? So a number which can which cannot be divided by some other number.
Yeah,
It should be 1 or either that number only. So I think 2 is a prime number,
yeah,
3 is a prime, 5 is a prime, 7, 11, 13. These are prime numbers, right?
yeah.
Yep. Okay. So, or what is this sample output 235? Okay, I think it's printing all the prime numbers. Okay. So in case of first one, right? So 1 is
Mhm.
not a prime number, so it's leaving it. It's not there, so that line is removed. So we're skipping that. Okay, makes sense. Okay, so we'll be having for loop int I is equals to 0, I less than 5, because we're taking 5 input. And we are doing this for system. Let me create a scanner. New scanner system.in, and we are taking input. I don't want to create another class for it. I don't see any good reason to create, but it just said that we need to create, so we can directly do this in main also. Shouldn't. Okay, never mind. Okay, we just want to check it. So we just want to check if it is a prime or not. Okay, makes sense.
For the prime, we have that logic, right?
Yeah, we know. If the number is less than or equals to 1, in that case we know that it's not a prime. Okay, so we can return false, right?
Yeah.
Um, otherwise, otherwise we should write some logic, So we can
That
just
there
write.
is one modulus logic.
Yeah, there is a modulus logic as well. So if a number is, if it's a 2, then we'll just return true. Now, the next logic is if number is modulo 2 is equals to 0, that means it's a false, because it cannot be divided by 2 again. So it is not a check, so it is not a prime number, right? Now
Yeah.
we'll just write code. So we'll say I is equals to 3. So we start from 3 and we go till n, you know, then we'll just say plus plus, and there is a logic for sqrt. We can use, instead of n, we can use sqrt. So I'll tell you later.
Mhm.
This is something which, not later, maybe. So even if you don't write, so it will just increase your time complexity. So I is equals
Okay.
to I plus you can also write this also. Never mind. Now if you say n, right? If
Uh-huh.
n modulo I is equals to 0, that means if a number is divisible by some I, right?
Yeah.
In that case, we'll just simply return false.
False. Yeah.
It should not be divisible, and I don't think it should be. It should be less than, should be less than n. Yeah. Um, and then we can just say otherwise we should return true and should be fine. Now let's take the input. So we'll just say um, sc dot next int, and we are taking input into a temporary variable, or you can say x is equals to input. Now we are just going to check. So we'll just call the logic prime dot check prime, and we will pass the x, and if it's a true, mm, that means it's a prime. Mm, this is
Sir, I checked it on Copilot last time.
mm,
It sent me a totally different. It was the code is kind of like yours, but they used is prime.
yeah, no worries. It is asked because it is asked here to write check prime, here. See, we have to get check prime. So we have a scanner SC, then we are taking the input, and after that we'll just pass it to prime. If it's a prime number, only we will proceed further. Okay. So if this is true, okay,
Yeah.
then only we'll just go through it. You know, we need to print the number, right?
Yes. For
So, so if it's a prime number, so we just need to print it. It should be less than. X I plus plus, and if, sorry, it should be J because we already have I. If check prime dot check prime J. So if it is a prime number, then we are going to print it, right?
oh, sir, that class prime was given before.
Where? I don't see it.
This, this down one, did you write it or it was given before?
No, no, I just wrote it.
Okay, 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 okay.
So if it's a prime, we'll just print it. I think that should work. We don't need anything else. That's it. Else, we skip it. Else we don't have to do anything. So yeah, it should work. So our code seems to not pass. Okay, makes sense. Okay. Should work now. So what is the issue? So the expected output is 2, 2, 2, 3, 2, 3, 5. Okay. And we got 2, 2, 3, 2, 3, 5.
We did get 1, 2, I guess.
Hmm.
But why does that 2 have to print again?
Correct, but I don't know why we are getting this. We have to check. So it should be something wrong with. Let's check. So if X is, if it is um, less than X, is there any constraint?
No,
Let me
they've not given
rerun.
one.
Okay, I don't know how it's skipping one. I think it's running for this, this, and this. It should not skip. Right. Let me run a try. Let me do a try run. Okay. Let's say we have 2 in first case. So let's say we got 2. So X is 2. We check if
Uh-huh.
it is a prime or not. So we got that 2 is a prime,
Oh, that's
So yeah, so it's a prime. So it will go through this loop, and we just want to print the 2. So in the first case, so j is 2. If j is less than or equals to 2, j plus plus, should not be like this. No. F prime dot check prime j.
so in the iteration for loop
What happened?
down
Wait,
in the
wait.
prime part, I think
Check.
you I is supposed to be less than math dot
Yeah,
sqrt
I know that
and
that we can do. That is just an optimization. I'll go through it. I was writing it down, but I removed that because you won't be able to understand the code,
yes, sir. That's why
So
I checked that code in
yeah,
ChatGPT
yeah, I know.
Copilot, but I didn't
So
understand
we
even what
can
it's saying.
optimize it, We can optimize the time complexity
Okay.
to make it log n. Oh, log n. I'm not sure if you know about time complexity and all, but if you have read the data structures, I think you should be aware of it.
Okay, so I'll check it once in Copilot what it means.
Yeah.
मेरे को प्लास्टिक नहीं मिला.
We are doing everything correct. I don't know why it's. I mean, so we have 2 here. We are going to print 2. So it is printing 2 for the first time. So this 2 is coming from there. What what is the issue, man? Why? What condition it's not taking? 2, 3, 2. Let me check. There will be only 4 lines of output. Each line contain only prime numbers depending upon the parameters passed to check prime. Hmm.
Check prime. Sir, they've in that thing they did private boolean is prime integer n.
No worries. That's not the issue.
Okay.
Prime check prime. In the other, we are having 1. So we are passing 1. Now for the 1, it will return false. So it will skip it. This is redundant. We don't want this. Okay. Now in the this one will be skipped, So this will be skipped. If there is no prime number, then yeah, we will skip. I think there is something wrong with the third case. Let's go with the 3. So we check 2, we'll print 2. It should be working. I don't know why it's not. I'm not sure why it's not. Let me do chat here. I don't want to waste my time on this. For every input x, if x is prime, print all primes up to x. If x is not prime, print nothing. But based on the expected output, the requirement is for each input number, print all prime that is less than or equals to number, regardless of whether the number itself is prime or not. What? So problem in your code is here you only enter the loop if x itself is prime. Oh my god. Uh, I got what was the issue. So if I remove this, it should work. That is not fair. Should work now.
Still
Mm,
not working.
mhm. 3 is a prime number, right?
3, yeah, 3 is a prime number, sir.
2, 3, 4. Don't know. Are we trying? Are we getting the question correctly? Let me see. Mm, we are doing exactly the same thing. I don't know what is wrong, man. Should be should be fine. True, false. I don't know. I think something is wrong with their statements. I think. But for
Sir,
the 2, we will be printing 2, right? For 1, we will skipping it, right? For 3, we will be printing 2, comma 3. So even if you check it out, so ideally answer should be this. So we are doing it
yeah.
correct, but I don't know, like what is wrong with them.
Sir, there is no 1. I think we have not declared 1 as a digit anywhere. Everything starts from 2 or 3. I don't know. That's what I think, sir.
Hmm? Check. Okay. So if it is, if x is less than 2, I mean, so in that case, we will just continue. Even still, like even the logic itself is a little bit weird. You see the input 2, right?
Yeah.
So 2 is a prime number, so we are printing
Yeah.
2. Okay.
Okay.
In this case, you see 1 is here, right? 1 is not a
Yeah.
prime number, so we are skipping it. Okay. Now we are going through the 3. Okay. 3 is a prime number, so we have to print all the prime numbers, right? So we will print 2, 3, right? So it
Yeah.
should not be 2, it should be 2 and 3. I don't know why.
Yeah.
I think question itself is wrong.
Yeah. There's a problem with the. I think there. Can we do it with custom input?
Even though if we do with the custom input, we have some, the backend is wrong. So the sample input and output is wrong. So let's go through the question again and let's see if something is we are doing wrong. We didn't understand it properly, but there will be only 4 lines of output. Each line contains only prime numbers depending upon the parameters passed. So in case there is no prime number, then a blank line should be printed. So that's it, man. Something is wrong with their output, sample output. So never mind. I'll just try to run the code. And all the test cases suddenly is not passing. I think something. So the main goal is to learn how to create prime, right? So our main goal is that only. This is crazy. Can't even see. Okay, this is the code which we got. So our main purpose is to go through this one. Okay, what is a prime number? So how to check if the number is prime or not? So that is our main concern. Okay. So if the number is less than or equals to 1, it is not a prime number. Okay. If the number is 2, it's a prime number. Okay. And if there is any other number which modulo 2 is equals to 0, then it is not a prime number, right? So we'll start from 3 and we go till n and I plus plus, and we check if the number modulo I is equals to 0. So we're checking if the number can be divided by that I. In that case, we'll return false. Otherwise, we can return true. But we can even optimize it. So we can say that if I is equals to math dot sqrt, okay, we can say like this. Okay. So we are just optimizing it for better time complexity. And yeah, so it should be fine. So we'll still get the same output. So we'll still get 2, 2, 3, 2, 3, 5. So this is the optimized version of checking prime number. Are you there? Ishan, I think you're on mute.
Yes, sir. My other device disconnected. I don't know. Hear me, sir?
No worries. So I think we have gone through these two problems.
Yeah.
Can you go through this solution and let me know if you have any doubts?
Okay, sir. Sir, what is that m dot sqrt?
So that is the way how we can find out the square root of a number. Okay. So by this, there is something math. This is something mathematically defined. So let's say if you have numbers like um 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this. Okay. Unless you want to find out the prime number, one cannot be a prime number. So 2, 3, 5, and the 7, these are your prime numbers. Okay.
Yeah.
And you are saying that I want to count the number of prime numbers from 1 to 10. So what are the count of prime numbers in this range? Okay. So we have n is equals to 10, right?
Yeah.
So to check or to count the number of prime numbers, or we can say that we'll start from 2, so 2 will be a prime number, so we'll start from 3, so we can say that count is currently 1. Okay, so we'll start from this
Yeah.
till this, and we say that if a number is 10, we can say we just need to check the numbers till square root of n. So this is something mathematically defined. What is the square root of 10? What will be the square root of a 10? So it should be
We'll
something
put the
3 point, right? It should be
3 point
something
something.
3.x, okay?
Yeah.
So what we need to see, so if we go to 4, right? If you go to 4 here, something like that, 4 or 5 maybe. Okay, square root of
Okay.
n should be,
Okay. Yeah.
what the hell? Suddenly it's not working in this case. Um, it should work though. We wrote the correct logic, right? But what was the logic again? Before that, we were saying that I is equals to 3. I should be less than, should be less than n I plus plus, right? So this was our previous logic, right? Here we are saying that if your number modulo I is equals to 0, in that case, we are saying it is divisible, right? So it is not a prime number. What is not a prime number? Your number n is not a prime number. So your number n, which is 10. Okay, so this
Okay.
10 is not a prime number.
Mhm.
So we don't need to check beyond 4. Okay, if you have 10 here, right?
Mhm.
So 10 is not a prime number. So if we have I less than n, it will check everything, right? I is equals to 3, I is equals to 4, 5, 6, 7, right? It will divide by each and every number. Okay, so 10 modulo 6, right? 10 modulo
10 more.
7, 10 modulo 8. Now you know already that it can, like, if you divide something by 4, so it will, mean, what was that? Sorry. N modulo I should not be. Why I'm getting confused? Such a basic thing. So if our n is a 10 and I
Okay.
in the first case is a 3,
Mhm.
so we know that if we divide something, if we divide 10 by I, it
Mhm.
will not be going to become a 0, right?
There will be some point value.
Yeah, correct. So we just increase the I to 4 this time and we check again. So 3 is, right? Yeah, 3 is not a prime. Sorry, 3 is a prime number, man. Why it is all messy again? I'm having difficulty explaining you this. Such a basic. Let's go through this. In this case, what we are trying to do, we are trying to check if the number is prime or not. Okay. So currently, let's say you have a number 10. Okay. Let's say you have a 10. Okay. Now you check the first case. It is not uh, less than or equals to 1. So it will not go through this one. Okay. And
Okay.
it is also not 2. So these two things will not be there.
Okay.
Now in the third case, sorry, in the third case, if you divide it, if it is modulo 2 is equals to 0, that means it's a false. Okay. So I think we are checking out the incorrect case. Okay.
Mm-hmm.
So it should not be a modulo 2. So let's go with something else. Let's say it's a 15. Okay. In this case, we will start from 3 and we will go till, let's say it's not a square root this time, it's a 15. Okay. Okay. So it will check each and every element, right? We
Mm-hmm.
just wanted to check 15, but it will check everything.
Okay.
What it will check? So what we are trying to check if the 15 can be divided by any number, right? So if it
Okay.
can be divided, so it cannot be a prime number, correct?
But why is 15 specifically, sir?
Because if for modulo 2 we already know that it is a false. Okay. So it should be something odd, which we
Oh,
are
okay,
trying to
okay.
check.
The n is 15 you gave in the start. I didn't see that.
Yeah,
Sorry.
if it's a even number, we
Okay.
already know that it is divisible by 2, so it cannot be a prime number, right? So even number
Yeah.
except
Is divisible by 2.
2 can't be a prime number.
Mm-hmm.
But if it is odd,
That's why we wrote modulus 2.
yeah, we can now go with
Go with what?
further steps. So in this case, let's say if it is 3 and it starts from 3 and we are trying to check for 15. So 15 cannot be that number, right? So 15 is divisible by 15, right? And it is also divisible by 3. So we check that it is divisible by 3, so it will return false. So let's say the number is 17. Okay. So now we have 17 and let's try to check it. Okay. So we'll run through the 3 and we say 17 modulo 3 is equals to 0. No. So we go through the again, we iterate again, and now I is 4. So 17 modulo, sorry, 17 modulo 4 is equals to 0. No. In that case, we'll write iterate again and it will become 5. So it will go till 16, right?
Yeah.
And it will still say no. So now we got that this is our prime number, we will return true. But if a number is very large, let's say if a number is something like and let's say 7. If a number is this large, and it can be a prime number, we are not sure now, but it can be a prime number. If a number is very large, this loop will run this much amount of time, right? You see what is the issue? If a number is very large, so the loop will run, let's say if a number is n, so this loop will run n minus 1 time, you know, so, or you can say n minus 4 time because we are starting from 3.
3.
Okay.
Yeah.
So if if we're taking a number n, so we are running it for n minus 4 times. So our time complexity is what? O of n minus 4, or you can say it's a O of n, right? So it's a very large time complexity. It's a linear time complexity, We can even reduce it. We can optimize it further. How we can optimize it? we can say even if it's a large number, it cannot go beyond math.sqrt of that number.
What
We
definition?
don't have to necessarily go. If it is going beyond the sqrt value, we already know that this is not a prime number. Okay.
Okay.
Or I mean, this is a prime number if you're going that beyond that number. So let's
SQRT.
say so n equals to, and I is equals to I plus 2. So again, this is again an optimization, but let's just do I plus plus only. This only. And we'll say that if a number modulo I is equals to 0, it's a false. Now, why I'm trying to say this, let's say we have n17, right?
Mm-hmm.
And we know that 17 is a prime number. Now, what is the square root of 17?
So, what will it
Should
be?
be something
Four
3,
point.
4, 4 point something, right?
Yeah.
So we know that the square root is 4 point something xx. Okay. Now my main thing is, if we are checking if it is modulo 3 is equals to 0, again 17 modulo 3 is not equals to 0. Okay. Now we are increasing again. Let's go to 4. Okay. 17 modulo 4 is again not equals to 0. Now why we are doing I is equals to I plus 2? Because we know the number is, if the number is divisible by even number, then it can be divisible by 2 as well, right?
Yeah.
So if it is divisible by any even number, we know that this is not going to be a prime. Okay. You see here, even number except 2 cannot be a prime. So if you divide any number by 2, or even if you can be able to divide any number by even number, so it won't be a prime, you know. So that's why we are saying I is equals to I plus 2, because we are starting from odd number. If we are adding 1 into it, so it will become even number, right? So we are
Yeah.
dividing it by even number, so that won't be any, since we already did this here, right?
Mm-hmm.
So we don't have to necessarily do this again. So that's why we are saying that I should be equals to I plus 2. This is very complex for you, I know.
Yeah.
For now, I'll go through it again maybe later.
Okay, sir.
And this one, even I remembered, like I learned it. It's very hard to explain this thing, why it's only going to the point. I mean, math.sqrt, it's very hard to get that.
Mm-hmm. I'll even check it once on Copilot.
Yeah, okay. Let's say the number is 27, so we have a square root 5 point something. Okay, so we go till 5, and n is your 27. So 27 modulo 5 is not equals to 0 again. So we go again to 7. Now 7 is your greater than the math dot square root value. Now even if you try however much time you want to try, you will still get the same result. That's what I am trying to say. This is
Okay.
something some mathematician must have derived. So just learn it, that we will use math.sqrt in prime numbers. Okay.
Okay, sir.
Or maybe we can watch some video. Prime number optimization. Hmm. So yeah, the first optimization is we check up to square root only. So the concept is, if a number n has a divisor greater than its square root, it must also have a corresponding divisor less than its square root. I don't know what it is, man. Just learn it. It's very hard.
Yeah, I'll go through it, sir.
Now the second is skip the even numbers. If it is divisible by 2, then it's not a prime number. So we can skip the even numbers. Okay, so we can skip it. You can iterate through 5, 7, 11, 13, and so on. Yeah, that's it. How this works. So this is also called a sieve of Eratosthenes. So the algorithm is sieve of Eratosthenes. Okay. Please remember this word.
Yeah, just write it. Those.
So this is an algorithm. This is something which you will not get intuitively. So the only intuitive approach I already told you, we iterate it till n point. So instead of using math.sqrt, we go through this point, and now this much is your intuitive. But the math.sqrt is something which doesn't come as intuition. You have to learn it because it's an algorithm. I think for
Yeah.
today this much is good. Please go through this prime number again. This is a very good question. Just go through it again and also try to learn what is sieve of Eratosthenes and why we are using math.sqrt here, not just normal, and why we are skipping the even numbers. Okay, even though I already explained you, but still just go through it.
Okay, sir.
So the major takeaway from that question was not the part here, it doesn't matter. The only major takeaway was this one. Okay,
Okay.
how to check the prime
Prime.
number. Yeah, and there is a 70% chance that it will come in your exam. How to check a prime number.
Yeah, this question has come many times.
Yeah, so you have to remember this math.sqrt, and I should be I plus 2, these things. Okay.
Okay, sir.
Yep. Um, so that's it for today.
Yes, sir. Even I have to go for lunch now.
Yep. Okay. Bye.